works. Okay, you already know that.
Arun,
Yes.
I want to just clear one thing.
Yeah.
That I have raised the request for the laptop, but in that I am in software specification. I didn't mention anything.
You can adding the basic OS and other stuff over there. And after that, you got some adding the basic that as we saw before, an SAP instance. Uh, when you log into the instance in SM50 code, you'll be able to see dialog work process, background work process, update work process pool, and update task work processes. But and when it is said that this dialog work process is working, or when you see some background job is being run by particular work processes, where the memory is being taken or from where the memory is being occupied, which part of the physical memory does has this program running at the background. So those things we need to know. Also, I logged into the system, my information and what C code I am using, my desktop information, the user context and all the other things where it is being stored. So those informations you need to know about. Okay. So first of all, this is a simple diagrammatic representation of the memory management. Okay. We have the physical memory. Okay, with OS swap, that is the operating system physical memory. Um, Usually, in older cases, virtual memory, I mean, there is one parameter called is physic mem size. Okay, that mem size, we have to define it so that all the processes will take within that page. Say, for example, if you specify physical memory size as 20 GB, all these activities will be taken care with the memory size itself. Can you see in this figure? CHYS underscore mem size is there, right? So in the older version, you have to
Yes.
explicitly specify the mem size so that all the other parameters we have to adjust it accordingly. But in the newer version, it is something like the physical memory size for Unix will be automatically taken care of. You don't have to explicitly mention it. It is automatically taken care of because the system can read the capacity, the memory capacity of the Linux box. So it reads by himself, and accordingly we have to adjust this parameters. These are all the critical parameters that we need to specify. ABAP slash heap limit, ABAP slash heap area dia, ABAP slash heap non-dia, ZTTA role first, ZTTA area, and all the ZTTA role extension. These parameters we have to explicitly or we have to configure it when you log into the system. Right after you install it, you have to configure these things. Okay. So if you keenly observe this diagram, the entire physical memory is shared parts by part. Okay. One is the heap memory. Okay. This heap memory is 8 GB. Typically, it will be 8 GB for almost all the application servers. And it is also possible you can increase it to 10 GB or 16 GB depending upon the hardware capacity and the requirement. Okay. What is this heap limit is the dialog work process and the non-dialog work process will take memory from this heap only. Okay. So above underscore heap underscore area underscore dialog is a dialog work process. Those actions or whatever the activities the processes are running now, those things will be taken care within this heap memory. Usually it will be 50 percentage. See, if it is heap limit is 8 GB, we can split it to 4 to 4, or you can if you dedicate that application server for only background process, then you can reduce the dialog work process memory to 3 GB and you can increase it to 5 GB for non-dia. Okay. But typically in the system, it will be 50 percentage only. Okay. Whatever heap limit you have mentioned, it will be split. Say, for example, I logged into the system. Let me check the parameter. Okay. I'm going to the T code RZ11. RZ11 is a T code to check the parameters. All the parameters can be checked with RZ11. Okay. And then you have to enter the parameter names here, ABAP heap area total. Okay, when you click display, it will show you this is the name and this is the type. It is an integer. The unit is byte. Okay, and this is the formula that is being used by default. It is also possible that you override this parameter. Okay, so here it is nearly 14 GB. Actually, for this many bytes, so it is calculated as 14 GB. Okay, so similarly, we can check other parameters as well. Keep total, dia and non-dia. Dia is for dialog word processing activities, and non-dia is mainly for the background. Okay. So for non-dia, we currently have 10 GB. Okay. So 10. What is the other one? And this is 40. Okay, so it should be 50. Total should be considered as a 50 GB. Okay, and there is two display buttons here. One is to know the parameter value. Okay, the other one is to know about the documentation of this parameter. What this parameter does. Those information can be read it over here. Okay, it gives you the metadata. Metadata means the parameter data about the data. So this parameter details, the short text, everything will be displayed over here. You can read it over here itself. Okay. So going back to the screen, so you have n number of work processes. Each and every work process will be initially given to em underscore initial size MB, right? This MB will be allocated to each work processor. Okay. And after the SAP system tries to complete the work by the initial size itself. But if it demands more, if it asks for more, if really the data that is being processed is more than this size, this MB size, then the memory from the heap will be used. Okay, and the Z role first and the role data are used for local memory. Local memory is the place where the user contacts, the user buffers, and all the other information will be stored over here. Okay, so what happens if there are more number of users and the heap memory is completely full? Okay, in that case, it goes to the extended memory. Okay, then the extended memory will be used, and even if the extended memory is completely exhausted, all the work process will go to the private mode. If all the work process goes to the private mode, it means that the system is completely halted, that you cannot do any other activity. Okay, so I repeat, each work process will be initially allocated to the initial size MB. Okay, so whenever the user logs in or he tries to perform any activities, SAP tries to accomplish that minimum memory at the first phase. Okay, but what if the demand is more? If the data that is being processed is more, what will happen? It tries to occupy the heap memory. It tries to eat up the memory from the heap. Okay, if it is a dialog work process, it takes ABAP heap area dialog allocation, and for non-dialog, BTC work process will be taken use. After this is used, heap memory used, and this memory is used, then it comes to the shared memory. Then the extended memory will be used. Okay. So once the extended memory is also completely filled, it means that the entire system is stalled. There are no other activities that is being used. So in that case, we have to reboot the server. We have to reboot the server so that all the memory gets freed up, and then the same process repeats. Work W0, W1, W2, the initial size will be occupied, and then goes to the heap, and then extended memory. This cycle it keeps on repeating. Okay. So if you see here, I'll give this block to you guys so that you can read it at your own time. So each and everything is having it is having a dependent parameter. Say for example, each and every parameter is dependent upon one. See, we cannot change this only one thing and leave it alone. Okay, you have to adjust all the other stuff as well. Accordingly, you have to. Say for example, the virtual memory, the total physical memory itself is 20 GB. You cannot have a heap memory as 25 GB or 30 GB or something like that. Okay, so everything depends upon the physical memory size. As long as your physical memory size is uh, long enough, then these are the typical values. Okay, the typical values of when you freshly install a system, these are all the default values in fact. Okay, so after that, slowly you can depend upon the usage and other stuff. You can slowly increase the heap limit, heap area dia, heap area non-dia, so that your system will be able to accomplish the incoming data or whatever it is. Okay. So here the questions will be how to avoid or minimize work process going to the private mode. When does the work process go to the private mode? All this information, you can just go through it. Okay, ST02, the system memory. I'll show you this. Actually, the other day, ST02, it actually shows you the buffers and other stuff. The entire system memory can be seen over here. The heap memory and the extended memory, what we saw in the diagram, right? Those things can be viewed here. Okay, what is the current usage and other stuff? You can see it over here. ST02. And SM04 is an interesting one. It shows you on per application server, what is the amount of memory each user are using. Okay, this user, what is the BDC user? How much memory he has used? Okay, he is using 2.074 memory, that is byte. Okay, if you take this user is consuming more memory. Okay, so SM04 is for user memory, how much the user is occupying it. Okay, and system memory is ST02 and ST03 is for programs and transaction memory. This also you should know. ST0. Actually, we can take a one entire class to understand this workload monitor, ST03. ST03 is a very useful T code which is used to identify the performance analysis. Say, for example, if the user is reporting that I'm not able to run my T code, the system is responding very slow during this period on this application server. So let me know what is the program that is actually causing the issue. So in that case, you have to come to this ST03 T code. Okay. So here you have to find it out the workload transaction, workload analysis. Okay. Last minute load, last minute what happened, those things, everything we can be viewing over here. Okay. ST03 is a Ubuntu basis. So you have to specify the date, time, everything. In case if you know the username also, you can specify it here. And when you click OK, here it tells you the workload overview. Okay, which is the how much time the background work process takes. Auto web, auto CCMS. CCMS is the monitoring thing. You will get to know that later. Okay, so all the details you can see it over here. The time profile is there. So at 5:30, what is the response time? What is the average DB time? What is the roll wait time? Everything you can see it over here. Okay, so ST3 is a boom. We also have ST0, ST80 as well. You slowly get to know those secrets. Okay. SM66 is the process memory. Okay, so it shows for all the application server. SM04, it shows for the user memory on that application server. See, I'm currently logged into app 2. If you see at the bottom, see my cursor, just follow my cursor. It is EU2 PRD ERP app 02. On this app 2, I need to find out the user memory. Okay, so for that, let me go to SM04, which shows you the users connected to this application server. But if you go to SM66, it shows you all the users connected to all the application servers. So it's not only two, it shows you 3, 1, all the application servers. You can see it over here. Okay. All the things will be seen here, the CPU time, the process ID, all the information you can see it here. And one more good thing is you can double click it to see about more about this thing. okay, where it goes or where it can be seen. Say, for example, this background job, if I want to know about more information on that, then just double click it. Okay. So when you double click it, it shows you that job. What is the job? It is a background job. The executing main program is ZOTC inventory PR running on the client 200. Work process user ID is WF batch. Okay. And it takes the gross memory is this, ABAP memory is this, heap memory. This has taken this much of heap memory. And these are all the programs that are being called within that program. Okay, so these are all the programs that it is picking up at the background. Okay, go to the DB statistics to know about how many hours recursive SQL is being called. All the information you can see it here. WP is the work process attribute. It is the work process number is 61. Process ID is 10514. It is in the running mode. Start time private cancel. Private cancel will happen only when the heap memory is completely exhausted. Okay. So all this information you can see from SM50 itself. So it is just this simple diagram that you need to keep in mind, so that all the parameters that are relevant to that can be easily adjusted according to the total physical memory. Okay. These things are not necessary, but up to this you can see it. Okay. So guys, if you have any queries about this, I have explained it in a very vague and a layman term. Okay. But once you start working on the production server, you will get to know about the dependencies of each and every parameter. How above underscore above keep limit is dependent to ZTTA role area or role first, whatever it is. Those dependencies you will get to know about once you start working it. But this diagram should be kept in your mind, so that whenever there is an issue, you can easily correlate to the parameter which is causing the issue. Okay, is it fine?
Yeah. And you please, Arun, can you please explain this local memory part uh, when it comes into
So
existence?
this local part, right?
Yes, yes.
Okay. See, this local memory is more about the user context. Say, for example, Shubham, you, myself, and let's take another one, Lakshmi. We logged into one particular application server. Say, for example, ERP app 01, application server 01. Okay. So once we logged into that, what are all the keywords that we are using, and our details like the time zone and our preferences. Say, for example, if you go to SU01, currently, I'm opening post admin, but assume that it is my ID. Okay. Um, so this log on language, date format, time format, even the spool control, what printer I should use, what is the time zone, what are all the parameters. These are all the parameters that comes under my ID. Okay. So these information, all the user related information will be stored in over here. Okay, this work process memory, it contains
Okay.
the user context details. Okay, see, for
Okay.
some, I'm going to perform an activity on particular work process. Okay, so that W0 work process will have an initial size of 1 MB or 2 MB, whatever it is. Okay, those activities, say for example, I am going to count 1, 2, 3, 4 up to 100 means those activities will be performed in the 2 MB memory. 1 plus 2 plus 3 plus all these activities will be taken care with that 2 MB memory. But my details will be stored in the local memory. Okay, like my name is Arun Kumar and my time zone is Eastern time zone. I am going to use a local printer LP01. My logon language is Germany. My parameter is this. All those information will be stored in the local memory. Is it clear?
Yes. Okay.
Yeah. Any questions, Ashutosh or Prashant? Don't worry about it. Even if it is a silly question, try to ask it. Okay, it's not going to bother you. The more questions that you ask, the more things you get clarified. Okay. Okay. So I assume that you guys are okay with this. Um, right now, I am not
Yes.
taking this testing memory limits. There is a way we can test the memory limit, but I'm not going to tell it because you have to log into the operating system to check that. For that, you need to have at least the basic Linux commands. You should get accustomed with the basic Linux commands. Only then I can explain it. But surely you will get to work on that part later. Okay. But before that, and we are just trying to put the basics only to you guys. Okay. Not going to dump you with all the information so that you get totally confused. You forget when you log into the SAP. Okay. So just have all the diagrammatic representation in your mind. Printing, okay, my printing will go to the spool work process. Spool work process is connected to, it can be directly connected to the printer, or it can be connected to a spool server. That
Server.
spool server, it can in turn connect to the n number of print servers. Okay, what are all the types of methods? Front-end printing is there, remote printing is there, SAP printing is there. So these are all the basic information that comes to your mind when I say SAP printing. So similarly, when I say to SAP memory, these things should come to your memory. Total virtual memory is there. That memory is split into shared memory, heap memory, work process memory. So each and every work process will be initially allocated with a smaller size of memory, 2 MB or 3 MB, whatever it is. And then whenever the process is getting started, that memory will be used at first. And in case if it demands more, then it goes to the heap memory. It uses the heap memory, processes the data. Still, if it demands, it goes to the extended memory. Okay. Once the extended memory is completely used, say for example, the extended memory is 2 GB. So if a process is taking more than this extended memory, that is the actual work process memory plus heap memory, that is 4 GB plus 2 GB, 6 GB, say for example 8 GB. Let us assume that it is 8 GB, okay? 2 GB plus 4 GB plus another 2 GB, 8 GB now. It really does wrong work. Wrong work in the sense SAP is designed in such a way that all the huge data, even if the huge data, should be get processed very quickly. That is the reason SAP is being developed actually. It is a processing of data, huge data. Okay. So no data should be ensured to occupy more memory apart from 8 GB, 8 or 10 GB, whatever it is. So my initial work process plus local memory, on the top of that is heap memory. After a heap memory is used, it goes to the extended memory. Once the extended memory is completely exhausted, all my work process will be going to private mode. So once the work process goes to the private mode, it means that my system is stalled. No user will be able to log into the system thereafter. The only way to come out of it is either you kill the work process or you have to restart the process. Clear?
Yes.
Clear, guys? Okay, fine.
Yes,
So
it
you
is clear.
go
Arun,
through this. Yeah, go ahead, Shubham.
no, no, I am asking about the table buffer.
Table buffer. Okay. Uh, so this we saw last time, right? Table buffers. You saw it, right? I think sometime before I covered it. Table buffer. Anyway, if you want, I can take it one more time.
Table buffer.
The same thing. Uh, this is almost more. You need to know about the data type. Um, okay. Actually, give it a little bit complicated if I can explain this.
Okay,
Uh, I
just
will
give the
tell you
overview.
in a very vague manner. Okay, you need not
Yes,
keep
yes,
this
yes.
memory, but you need to know about what a table buffer is. Okay, hold on, one second. Okay. In SAP, there are some tables called types of tables. Okay. One is called transparent table. Another one is called cluster table. Another one is called structure. Okay. These are all the types of tables we have in SAP. Okay. Transparent table is nothing but straightforward a table. Okay. You log into system, go to SM16, USR02. Okay. So this table is a transparent table, meaning that this table exists both in the application and in the database. Okay, a transparent table is nothing but a table which is available, which is physically present in the application, in the database, as well as in the from the app you can see. From the app, in the sense, they call it as data dictionary, DD. Okay, data dictionary is nothing but and in the application layer, you'll be able to see that the application layer of part is called as data dictionary, but the data dictionary sometimes refers to the DB as well. Okay, I don't want to confuse you. Now, the transparent table means both app and DB. That's it. Keep it in your mind. Okay. Cluster tables are tables which are not present in DB, but only in application. Means that, say for example, I have a table T1, T2, T3. These are a transparent table, which means it is physically present in the DB and as well as in the DB, as well as in the application server. Okay. In some cases, the ABAPers or the functional guys, they will develop a table by doing inner and outer joins. Have you heard of inner joins and outer joins?
Yes, yes.
Okay. They will create inner and outer joins and create some funny tables. Okay. So that table is called as a cluster table. Say for example, TCL1. Okay. This TCL1 is not physically present in the database. It will be seen only in the application cell. Only when the application is started, you will be able to see this table. If I log into the database, you cannot see this TCL1 table. Okay. So this is not a transparent table, but a cluster table. It is a cluster of tables, that's it. Okay. And there are things called structures. Structures is more or less cluster table, but with more flexibility. But with more flexibility in the sense, these structures will be lesser in size, very lesser in size. Only on demand. If you need it now, only then the application server will perform this inner and outer join. Okay, and then it creates a table and then it pulls the data from the database. That's it. And it deletes at the time itself. Once the program gets completed, the structures also will go off. Okay, so that is called a structure. Okay, now comes the part of table buffer. Table buffer in the sense, see, as we said, user buffer in ST02, whatever we have seen here. Okay, this table buffer, there are certain tables you explicitly mentioned to keep it in the buffer. Sorry guys, that's my kid. 1 second. Hold on. Sorry guys. Okay, so ST11 is a T code where you see the structure and the other things. structure of a table structure and other details. Okay. So if I open this table, it shows that it is a transparent table. This is a description. Okay. These are all the fields. Okay, and the corresponding data type and other stuff there. We go to the technical settings. See, USR02 transparent table, it is developed by SAP. The status is active. If you come to the buffering part, it shows that buffering allowed but switched off, which means that this table is currently switched off. It will not be placed in the user buffer or in the table buffer. The table buffer is a buffer which is specifically allocated for the tables that are being accessed very frequently. Okay, so in that part, this table is switched off only when if it is demand, it will be pulled in. Okay. Also, the buffering type is single record buffer. Single record buffer in this means what does it mean is only one record will be fetched at a time. Which means, say for example, if I log in, if Arun Kumar logs in, or if Shubham logs in, what SAP does is it goes and checks this USR0 table, looking for only Arun Kumar's record. Okay, and my details, what are all the details that are present in USR02 will be fetched in and it will be put into the user context table. Okay. Even if it is confusing, that is okay. Don't worry about it. As of now, you need to know about what is a buffer, table buffer. It is just a buffer which holds a table. There are three types of tables: transparent cluster structures. Transparent is both physical and it will be available in DD as well as in database. Okay. Transparent table, if say for example there is a table which is 5 GB or 6 GB in that 6 GB in size now, those tables will not be put in buffer because that one single table itself occupies 5 GB now, then obviously the other tables will not be easily swapped. Okay, so huge tables will not be put in buffer. Point number one. Very frequently accessed tables only will be put in the table buffer. Okay, structures and cluster tables are definitely not put into the table buffer. Okay, and those buffer details you can see it from ST03, ST02. Sorry. Okay, this information is enough for you guys. If I take more things now, you will get a little bit confused. So